So our goal for today is to come to a class consensus. A class consensus, and all agree upon what actually happens at that 5-second mark. Okay? Now, if our goal for today is to finally agree, what does success look like? How will you know if you are successful at the end of the period today?
With the teacher agreeing with us.
With the teacher agreeing with you?
Yeah.
Okay, Yazin?
The whole class agreeing with us.
With the whole class agreeing with you? All right, I like that. What were you going to say?
Same thing.
Same thing. So what will they agree with you on? What will you be able to do? What will you be able to successfully do at the end of the period if you got it? What will you be able to do?
Explain what happens with the red and the 5 seconds.
Explain what happens. So in detail, at the end of the period, you'll be successful if you can explain what happens at that intersection in 5 seconds. And if you can get everybody in the classroom and me on the same page as you. Think you can do that? Okay. Before we get into our circle, I'm going to give you a couple of minutes to make any changes to your board. Now, yesterday before we left, you wrote down on your paper, before you moved, you wrote down on your paper, right now I think. Yes? I want you to find that paper from yesterday. I want you to read what you wrote, where you were thinking yesterday before we left off.
You change your answer.
Take that idea to your group. Take that idea to your group so that you can fix your board as necessary. Ready, set, go.
Miss Harwood.
Wait.
What if A's going and then B passes right in front of him and then it forms the F?
So like A goes first and then B goes next?
Yeah. Because then it isn't stopping.
He says no because it's the same time.
I know, but like if they stop, there'd be a crash. That's why you can't stay the same speed if you run into each other.
Look at how the line is shaped. Like B's technically slower. He's going slower than A. Because it makes sense when you think about it that way. Because wouldn't it have to slow down? So how
Maybe they just kind of like hit wheels.
How does it crash? They just bump into each other.
Well, then the answer would be they bumped into each other then.
But they didn't. They just ran past each other.
So how can you have to figure out how can you be on a bike and be in the same place at the same time?
If they're on the y-axis, then they're at the same distance from where they were before, but they're not at the exact same place.
I'm saying, like, see, we're at the same distance right now. It doesn't matter about all the directions.
Okay.
But are you, if you're looking at the graph, when people look at where the lines intersect, how can you argue that being next to each other is the same position?
Because it's the same distance, they're not in the exact same place.
So how can you prove that? Can you use math to prove it? Can you use the lab to prove it? Think about how you can prove it. Get back.
Exactly. No, it's not. It's nothing to do with it.
How do we identify the position?
No, wait, what one is like one dimension, the other one.
So that's not the same position. Is that the same position?
Different. Even if it's like 5 centimeters, it's still different.
So there's a bridge.
It's not.
No. It just jumps over.
There's a line. What is this line?
Because it's a starting line. Okay, where did you get the starting line from? Are you making things up? This is the You said there was a bridge, okay? This is not on the graph, this is just a picture.
This is a picture.
This is not related to the graph.
I understand.
Oh, yeah.
Okay.
So let's say 1 second. Okay? And if you look at it this way, so this is the order.
Does the origin have to be a dot? Like if you're thinking,
If you're thinking about an origin and reason, does it have to be a dot?
yeah, like the bicycle. Or wouldn't the starting line
Well,
be a line?
isn't the origin a point of reference? So you can define, so you're saying the origin isn't a dot, it's a starting line.
So if it's a line, then it doesn't matter. There could still be a bridge.
Or there could be a bridge.
It's not a bridge. It is not a bridge.
How do you know?
Because that's
You're saying there's a starting line.
Because if they're both in the same line, then both of them are gonna go over the bridge and crash on the bridge.
No, it's just like
Listen to Jason, it's
it's
like
a special.
how does your bridge work?
No, actually, it just jumps over.
Oh, he jumps! He's like a,
yeah.
Jumps like a line of it.
why would the line be different?
There's no gravity. It's so simple.
If there's no gravity, how would he come back down?
He does it.
That's even more. I'm so lost.
You're just making him more.
So we have to agree upon an answer. We have to come up with an answer.
Okay.
No.
It's 2 to 2.
No, they just
Why do you?
no, they just crash into each other.
No, because it's
And then-
two beats.
Well, you have to convince him why is
Oh,
crashing
no.
into each other wrong.
No wait.
If they crash into each other, then
This
this
is the B
line.
line.
Because then they
line
can keep
is
going on.
This is the line for B. This is the line for A. They're just like this.
Look, Jason, if
And then
they
they bounce off
crash,
of each
if
other.
they crash, the line would end.
They crash and then bounce
Line
off.
for A wouldn't go over here, and the line for B.
So your argument to Jason is, what is your question to Jason? What question could you ask? How?
How old are you?
Yeah. How would the lines keep going on if they crash?
I don't know. I'm just making.
But the lines do go, so that shows that they didn't crash.
Well, you see, they bounced off of each other. It changed, right?
But that'd be different colors.
But this is A, and this is B.
Line.
Remember the 3 rules. Rule number 1, no side conversations. Rule number 2, raise your hand to talk. And rule number 3, you have to ask a question or answer a question that was asked of you. Check the boards before you raise your hand. So take a second to read first. All right, Anthony.
So, Amy's board, you think they cross? Why?
Because that's their graph showing, and there's like no other way that they could be at the same place at the same time without crashing.
I thought.
Is it a question?
Sorry. No, not. I mean.
Oh,
it's
you want to make it a question?
Yeah.
Okay.
I thought the graph is like how fast they're going, like the steeper they are, not the path, right? Or is it the path? I don't know.
What's your question?
No,
He's saying is the
Are you
graph.
saying is the graph the path?
yeah, it's the graph.
Does the graph show the path? This is question.
I mean, it kind of, it shows that they like meet at the same place, the same time. They couldn't do that without having a bridge or something.
Lizinski.
Ellie, how can you prove that two things can be in the same plane at the same time?
Oh, good question.
Okay, well, if you imagine 2 people and, well, you can imagine the bikes. Like, they're going like this. One is going at a more uphill and then one's going, like, more that way. Imagine, like, 2 things can't be in the exact same place. Like, just think about it. Can 2 people be standing in the exact same place at the same time? Like, no, because, how? Like
two people standing
so the exact same place, like the actual exact, because those lines, like, they're both in the exact same place. They're not next to each other. They're in the, like, the same.
Joshua.
You said going uphill. How do you know that?
That's just what we think.
Is he?
Couldn't the people be like on top of each other?
Yeah, that's what we said. We said that.
So your argument is if I had like something on my shoulders, we would be in the exact same place at the exact same time.
Yeah.
Okay. And you can't. And your argument, I'm understanding, is you can't do that on a bike.
Mm-mm.
Okay. Carl.
How can you be the exact same place at the exact same time if you have somebody on your shoulders? That means that they're like not equal vertically level with you, they're above yours.
Okay, that's not what we said though. We didn't say that they were on their shoulders. We said that one was on a bridge ahead. And if they were lined up perfectly, they would be.
Well, yes, but like I said, they're not on the same elevation. They're not in the exact same place.
I mean, when I think about it, they would line up perfectly though. So on the graph, if it was like an overhead view, you would see them lined up perfectly, like it was on here.
Aaron.
How can you prove they're at different elevation?
Well, kind of what I said before, like they can't be passing each other because they wouldn't be in the exact same position. That's the only way, is if you saw it like from above view and you saw them one on the ground level and one ahead or below.
You guys look like you were like arguing, so are you guys saying there's a bridge or are they going in a parallel path?
Well, personally, I think they're going in a parallel path, and so I think B is getting a head start, and it's going slower, and it goes faster. And once they're at the same point right here, that's where they intersect on the graph.
Yeah, because it says it near.
Yeah.
But, and then Lewis, you're on the bridge. You're on the bridge. Okay, and what about you, Aiden?
Parallel.
Parallel. Okay, so I think we have two main ideas. Correct me if I'm wrong. We have the idea that they're going parallel to each other, and it's kind of like this, like Arden just showed us. Or the idea that they go some variation like this, but that there has to be something that puts A on top of B or B on top of A so that they can be in the same position at the same time. Would you agree? Okay, I want everybody to think about which side they're on. Think in your head, which side am I on? All by yourself. You don't have to discuss. Or drop your board. It's okay. All right, now. We've asked a lot of questions. I want you to think in your head, is there anything we could do to prove it? Is there anything that you could do or a question you could ask that would prove once and for all to get us all to success today that your answer is right versus the other answer? Getting attacked here. What do you think, Arden?
What if we could use some of the cars that we used in one of the other labs?
So what do you mean by use the cars?
So maybe we could kind of like almost chart it, like what they're doing, like use a faster car that's one of the faster cars, so that could be used as A, and then you could use a slower car that could be used as B, and then put them in a parallel line, and then have B be put at a little bit faster start, and then see when they kind of, and then kind of like chart it, I guess.
But how would we solve the bridge? Like, how would we do that?
I don't know for the bridge.
So if we tried the parallel lines, what you want to do is you want to use the car, let me make sure I get this right. So you want to use the car as a fast and a slow car, and you want to see if we get this graph.
Yeah.
With the motion detector things, or what? Or like,
I'm not sure for that part.
What do you think?
Thinking with the motion detector thing, we did that lab.
Uh-huh.
We had to walk and get the slope.
So you think we could use her idea with the cars and use the motion detectors and see if we get this graph? Would that give us a final answer?
Yeah.
Okay, let's try it. Okay, so if we do this and the lines cross and they don't crash, then we will know that the lane theory is correct. Am I right? Will we have reached success if we can see that on the screen? Yes. All right, are we ready? On your mark. I'm excited. Get set. Go.
Wait, how do you turn this off?
They were never. Right. So what's the argument? What do you mean they were never in the same? Put the cars back right there. Okay.
Never mind.
Okay. Arya, do they?
Should I stop it?
No, they did touch.
Should I stop the video?
I can zoom in. Let me see if I can zoom in. No, they do touch. Right there, they touch. Yeah.
But the cars weren't in the same.
Right, that's right there.
Brandon.
Okay. So listen. Can you move the cars equal distance for me? Like move it like from the origin. So no, up that way. So like at 5 seconds, like where they would be at 5 seconds. Okay, that's perfect. Alright, so, Arian, Bethany, when they are side by side, you are correct that they are not on top of each other. They are not in exactly the same, I'm going to use the word spot. But if we were to take and graph this on a graph, think about what you would do. You would measure how many meters away from the origin. You would go up and you would make a dot, right? And then the other car, you would measure how many meters from the origin. You would go up and you would make a dot. And so that's how you get the cross on the line. Don't be disrespectful. That's how you get the cross on the line, because they're not in the same exact spot. They're the same distance from the origin. Does that help?
Yeah.
Yeah.
Like that's what I was saying on Friday. I said that we basically agree on that, but we just have different definitions of position.
So now do we have the same definition of position?
No.
Yes, we do.
I mean, another way you can think about it in a bigger picture too is you can think about it in kind of like in latitude and longitude, right? Like we can be in the same latitude and longitude, but not sitting on each other's lap, right? So I see what you mean by like it's more of a wording thing than it is a measurement thing. All right, have we reached success?
Yeah.
Do we all agree?
Yeah.
Do we all understand how to explain for the pop quiz that's coming up? Do we all understand how to explain what is happening at the intersection of the lines? Do we need someone to do it for us?
Yes.
We would like someone to do it. Who feels confident that they've got it and they can fully explain? All right. Come on, you can do it. Come on, you can do it. I want you to explain what is happening with the intersection of the lines.
Oh, okay. Basically, one car is moving like slower than the other, and then when they both reach the same like position at the same time, then they cross, and then.
What's they cross? The cars cross?
Yeah. No. They like.
The lines cross on the graph?
No, the lines cross because
Excuse me. Listen.
Because like car A goes starts moving ahead of the other.
So at the intersection of the lines, the cars will be next to each other because B is going slow and A is going fast. And so think of it like being on 400. Here's B going slow and your mom's in the left lane. How fast she going? 70. No, she's going 70. And so she's going to pass by the opposite car. Yes? All right. All right. And last period it was a Lamborghini and a Honda Accord. Honda Accord's actually
go up to
pretty fast.
55 miles.
So, really quickly, we're going to do two things. But the first thing is, if we go back to our original assignment, a lot of us either had the wrong answer, an answer that was not specific enough, or an answer that needs some editing. Now I hope you have a visual model to go with your picture. I want you to go back to your original paper, and I want you to make some sort of a change, whether it's changing it completely or adding to it. All right, let's do that. The slope of the line tells us, what does the slope of the line tell us? The speed or velocity. Okay, so the speed, or velocity. Okay, speed which does not include, or velocity which does include, what are we going to pick for that one? It does include displacement, but what is, there's a better word I think we could use other than displacement. Direction. See the difference? So the speed is the distance. So we're going to say direction. All right, then over here we're going to draw some graphs. Now when we draw our graphs, make sure we write position and time. So let's draw 3 axes to start off. So an axis, time, position, time, position, time, position. Okay, now we're going to draw in our graph so that we can refer back to this. All right, let's think about it. The first one says that we're doing a graph towards the origin. So remember our slope meter? Let's use our slope meters. What would our arm look like for towards the origin? Towards the origin. What kind of slope is it? Positive or negative or zero? Negative slope. Very good. All right, what if our object is not moving? I've already seen arms up. Very good, very good. Not moving. What's our slope? Zero. And how about away from the origin? What does our slope meter look like? Positive. And if you want, you could be advanced, and you could label 1 what and 1 what. What does a steeper slope mean? It's going faster. So you can label one fast and one slow. All right, how do we feel about this? Yes, Catherine?
Can we draw the graph that we just did?
Sure. All right. So we can also draw, well, I'm going to put it up here. I think you have room on the bottom. All right, we'll put a graph that we just did. A, B, position, and time. And what do you want to add in about the graph that we just did? That we just talked about? What do you want to put in there? Okay, so we can put a little dot there and we could say, you want to say side by side? Side by side. Do you want to write not crashing, no bridge? Okay. Awesome. Do we feel confident about constant velocity? Yes. Yes. Have we reached success? Yes.